So, good afternoon. Today I will speak about my internship at SSE9, my last internship. So the topic is antenna optimization for LiDAR application, and more precisely for solid-state LiDAR. So a solid-state LiDAR is, as the pointer, a laser source, light source, and the goal is to make it move like this to collect data in the environment. Okay. So the internship was in collaboration with SSE9, so to steer light, as we can see on the second figure. And the LiDAR is on the left figure, so the right for you. No, the left for you, the right for me. And it measures as 1 millimeter, so it's a LiDAR on a chip. So to steer the light, we use an optical phased array. So an optical phased array, the common one, look like this. And we inject light into a fiber coupler with the fiber. And the light is propagated inside this, and divide inside the power splitter into several guides. So the phase is controlled in this zone, and we can make the spot move in the free space like this. So with this type of optical phased array, we make LiDAR, but we can see in near field here that we have some trouble because the goal is to have a well spot as the marker point. But here we have a lot of trouble and interferences. And in far field here, we can see several spots in far field. So many spots, and we just want one spot to collect data. So why have we this problem, this issue? It's because we want to, each antenna works as an emitter, and we want maximum interference in free space. And to have this, we need a pitch, so distance between two antennas of wavelengths over 2. Instead, we have several peaks. So it's called grating lobes. And why? Because when two guides are too close, when the light is guided into a waveguide, we have an evanescent field, and this evanescent field is coupled with the other guide, and all the light is transferred from a guide to another one, and we lose the signal, and we have interference between all the guides. So how to solve this problem? It was the topic of my internship. So we make a large antenna. So instead of having a lot of waveguide, we have just a big waveguide, and we make interference inside the guide in the silicon. And we extract the light in the same way as before, but in the large antenna. And by making this, we can remark in near field, so close to the guide, that we have a not well spot, but because of the FDTD simulation, we have some trouble, but in near field it works. And we have an angle because we apply the phase of 3 degrees here, as we can see here. And we can remark a well-resolved spot, a thin spot, so that works well. And we can make a great spot and a LiDAR with this kind of technology and control the phase. So we can control the angle and collect point and reconstruct the environment. Thank you.